Hey, welcome. Today we're looking at 311 transformations. We're going to be looking at transformations of different functions. Um, it's something you guys may or may not have covered in Algebra 1, but we're going to look at it today. If you take a look at our parabola here, we change colors. This is the graph of y equals x squared. So what we know about y equals x squared is that it's a parabola. It opens upward as we go towards negative infinity, it increases on both sides. It's also centered at 0, 0 at the origin. The vertex is on the origin. Now what we can do with this base graph, right? So this is like the standard y equals x squared graph. There's nothing changing the parabola or transforming the parabola, is we can add these things to it. So if we have a number in front, we'll call that a, and then we'll see what a does to the graph of our parabola. We can also have inside of the function, right? So the squared of x is the function. Inside of the parentheses, we have the minus h thing. So that's something else that can change our parabola. And also we have this plus k outside of the parentheses or outside of the function. And we'll take a look at what that does. So for a, let's pull up Desmos here. So we'll put in, y equals x squared. And we see that's the same parabola we were looking at the very beginning. Now let's look at what the different functions or transformations do. So if I put some number in front of a of x squared, we'll call it a. So let's say y equals, and let's put a of x squared. Okay, and we'll put a slider in here and we'll kind of look at what this does. So this is one of the cool things about Desmos. Let's move this graph down a little bit. So as long as, if a is 1, 1. Okay, good. That's it's overlapping the red graph, meaning that's the same graph as x squared. And it makes sense because if a is 1, then 1 times x squared is just x squared, so nothing changes. Now notice if we make a negative, so I'm going to pull this slider to when it's negative. Notice that it's the same graph except for it's flipped upside down. So we'll go back over here. We'll say that if a is negative, then it flips vertically. So this flips. That's not how you spell flip. Flip vertically. So what happens is it takes our parabola, turns it upside down. If a is positive, then it opens upwards. Now let's see what happens if a is between 0 and 1. So what that means is that it's a decimal, but it's still positive, or some fraction, but it's still positive. So let's look at this. Let's say we do 0.4. So notice what happened here is that the graph got wider. We call this a vertical compression. So as we get smaller, well, let's go back here. As we get closer and closer to 0, it gets wider and wider. So this is one of the questions they're going to ask you on your assignment. So let's note that. The parabola wider. And this is called a vertical compression. So compression means to squash, right? So we're squashing it from the top downwards. Okay, now if a is greater than 1, let's see what happens there. So as a gets bigger and bigger and bigger, it stretches it, which means that the parabola is getting skinnier. So let's change colors here. So if A is greater than 1, then this is going to be a vertical stretch. And then that means the graph is skinnier. All right, and then the H stuff, the inside, let's do another graph here. Well, let's get rid of this. So let's say y equals, and we'll put the parentheses, x plus h. Oh, sorry, x minus h is the format. Be careful there, and it makes a big difference. So minus h squared. So we're going to add a slider to that. So let's say h is 0. If h is 0, there's no change in there. X minus 0 is still 0. So we should be right, overlapping. It's not cooperating. Okay, so it should be overlapping the red graph. Now, if we make h positive, then it moves to the right. But be careful here. Let me undo this slider. So let's say we have minus 1. Right, so notice that the graph has moved from the red 1 unit over to the right. So if I do minus 5, then we should expect it to move 5 units over to the right, which is what happens. Now, what happens if we have a plus? So if we have a plus 1, then it moves to the left. If we have plus 2, it moves to the right. To the left 2. If we have plus 6, it moves to the left 6. So the thing to remember here, right, and it's one of those things that you just kind of got to remember or do it enough times that it just becomes natural, is that if we have a minus h, because we start off our equation in the form x minus h squared, if we have minus h, that moves to the right. If we have a plus h, it moves to the left. And it's counterintuitive because you'd think plus means positive, so we're going to the right, but it doesn't. And minus means negative, so we're going to the left, but it's flip-flop. So one way to remember it is that inside the parentheses, it's maybe not flip-flop, maybe that's like a not so good term, we'll say is reversed. So anytime we're talking about transformations and translations inside of the function, a plus will always go to the left, a minus will always go to the right. It's just reversed. Now outside RK, let's go back to our parabola here. Let's erase this. Actually, let's just do x squared, and then if we add outside of our function, so this is outside of the squared part, anything plus goes up, anything minus goes down that many units. So plus k is up, minus k is down. So if you can remember all these things, these ideas apply to all of the functions that you'll ever see. So again, remember a, if it's positive, it opens upward. If it's negative, it's flipped vertically. If a is between 0 and 1, we have a compression vertically, so it looks like it's getting fatter or wider. If a is greater than 1, then our graph gets skinnier or is stretched vertically. Inside of our parentheses or inside of our function, negative h goes to the right, a positive h goes to the left, or minus h plus h, I should say. And then plus k is up on the outside, minus k is down on the outside. So let's go ahead and get into our Alex assignment. I'm going to do the example straight from your assignment so that it's a little bit clearer exactly what you're supposed to do. All right, so let's start this. So the first question is asking us, translate each graph as specified below. The graph of f of x squared is shown. Translate it to get to the graph of x squared plus x plus 1 squared, excuse me, for part A. So remember, x plus 1 inside of the parentheses, that's the one where it's reversed, right? So instead of going to the right 1 unit, this is going to move to the left 1 unit for part A. For part B, it's saying the graph of y equals x squared is shown. Translate it to get to the graph of x squared minus 4. So notice that the minus 4 is not inside of the squared part. It's separate, so that means we're translating vertically. And we know that minus means down on the outside, so we're just going to translate this down 4. We're going to check it, and we should be all good. All right, let's move to the next type of problem. Okay, so this one has a couple transformations, right? So there's an inside transformation, which means we're moving left and right. And then there's an outside transformation, the plus 1. So then let's do this one at a time. So inside we have x plus 3. We remember that inside of our parentheses, inside of our function, if we have a plus, that's actually going to the left. So we're going to move it 3 to the left. And then the plus 1 on the outside means we're going to go up 1. We're going to check our work. And we got that one correct too. Awesome, we're on a roll. Okay, the next type. So this is an absolute value function. The two lines are saying absolute value of x. And all that means is whatever x is inside, what we get out is positive. So if we have a 3, the absolute value of 3 is 3. If we have the absolute value of negative 3, that's still 3. Whatever's inside is always positive outside. So this is the graph of it. It's V-shaped. The slope is 1 on both sides. And what we're going to do is we're going to apply the same idea. So notice that for the first one, we have x minus 5 inside of the absolute value function. So remember, again, inside, minus goes to the right, plus goes to the left. So we're going to translate this 5 to the right. On the one below that, notice the plus 1 is outside of the absolute value. So that one we're going to go up 1. Check our answers. We got them right. All right, so these ideas apply to all the different types of functions. So this next one is going to be a combination of transformations again. Notice we have plus 5 inside of our absolute value and plus 3 outside of our absolute value. So that means, again, inside, plus goes to the left, so we're going to go 5 to the left. And then the plus 3 is up and down, so we're going to go up 3. We're going to check our work. And then we should be all good again. All right. More absolute values. All right, so this last part, it's going to ask us to look at the graphs below, then fill in the terms about, fill in the information about the coefficients A, B, C, and D. So notice that for the first part, right, it's asking us for each coefficient, choose whether it is positive or negative. So for the first graph, A, x squared, notice that it opens upward. So what we know that anytime if our graph opens upward, we should have a positive. So same with graph B is also positive. Now C and D open downward, so those are both negative. So again, if it's positive, opens upward. If it's negative, it goes downward. So part B says choose the coefficient closest to 0. So what we know from our notes here is that if A is closer to 0, then it makes the graph wider. So we're looking for the graph here that's the widest. It doesn't matter if it's up or down. We're just looking for the one that looks the widest, and I think that one looks like D. Right? So The thing to remember there is as we get closer and closer to 0, the graph gets wider and wider. And then for part C, it's saying choose the coefficient with the greatest value. So remember, as our number gets greater and greater from 1 on, well, anytime it gets greater, what happens to the graph is it gets skinnier and skinnier. So we're trying to find the one with the greatest value, so we're trying to find the one with the skinniest graph, which to me looks like A. Okay, so we're going to check our work. Looks good. More of the same, this time with absolute value function. And then ending with one last one. It says the graph of y equals x is shown on each grid in parts A and B below. Use transformations to get the graph of y equals negative 1/2 x squared. So remember, oh, this is a weird one. I don't know why they have the negative 1/2 in the parentheses. That's something that we're not going to talk about. All right, well, anyways, skip the last one for this one. I'll give you guys full credit. So make sure you have this handy when you're doing the transformation stuff. We're going to spend one more day doing this next class, so you'll get more practice on it. But if you have any questions, please bring them to class. We can clear them up, and good job.